This is my only lecture for convex mirrors, and you're going to find that you've already laid down all the groundwork you needed with concave mirrors. Remember, a concave mirror is a mirror that opens like this with some principal axis, center of curvature, focal point, and based on where the object is located in any of these 5 spots, here on the center, between here on the focal point, or in here, the image is going to be in a variety of places. But what you're going to find with convex mirrors is it's much more simple. So I'd like to take the 5th case of, let's say the object was placed right here. If it's placed right here, hopefully you remember from some concave episode that the image is going to be a virtual image that is back behind the system. And there are ways of documenting this. You can draw a ray diagram if you want, but I'm not going to do that here. But I just want to point out that if I switch the mirror, let's make it go this way. Well, it's like a concave mirror turned 180 degrees. So if I take any object, I'm essentially putting it behind the concave mirror. That's what I'm doing. I'm putting it behind the concave mirror. Only we call this a convex mirror. But essentially, if I put any object behind here, it doesn't matter what it is, the image, just like this, transitioned, or I'm sorry, this transitioned to this. This image came from this object. This object is going to transition into an image that is going to have 2 properties. Number 1, it's going to be upright, and number 2, it's going to be smaller in size. So it's going to be somewhere over here. It's always going to be less than the focal distance away. Because right here, the 5th case for concave mirrors said that we were inside this focal length. So this has to be inside the focal length as well. So I don't know if that kind of explained it, but that's the basics behind convex mirrors, or that's as much as I'm going into it. I want to talk about conventions again, because I know that was a fun discussion. And with concave mirrors, we had a bunch of rules. Well, guess what? There are problems with convex mirrors that require math and formulas, but those formulas are the exact same. You're still going to use the magnification and mirror equations as before. So you're still going to use 1 over f is 1 over do plus 1 over di, but you have to remember that for convex mirror systems, f is just always negative. For concave, we assumed it was positive, but because we have a situation like this, where we assumed that this focal distance was positive, well, the focal distance has to be over here. Right? It has to be over here. So since it's going in the opposite direction, we call that negative. And that means the image distance is in the other way, so it should be negative as well. So what I'm going to do is I'm going to shortly go through each of these 4 problems. And I'm not going to solve them, give you numbers. I'm just going to set them up and show you the conventions, because I think that's the most important thing to get out of this. So I'm going to write these equations up here. So this is the mirror equation. And this is the magnification equation. All right, the first question says, a convex mirror has focal length of negative 10.8 centimeters. Well, if this convex wasn't here, you'd still know it was convex because of the negative focal length. But if you document it, you have convex mirror with the principal axis. If the focal length is negative 10.8, then this is the focus. That's the center. I just want to make a note that this distance is equal to this distance. Alright, so this focal distance, you can either say that this is 10.8 or it's a negative 10.8. Either way, when you calculate it, you have to put this negative sign in there. But if you know that if you put a 10.8 and you're moving in the right direction, if you know that that's negative, then you don't have to put this negative sign. I like to, just because I get confused a lot and it helps me keep track of everything. An object is placed 32.7 centimeters from the mirror's surface. Okay, so this positive 32.7 tells me I'm going to put it over here. Okay, so this distance is 32.7 centimeters. So if they want the image distance, you're probably going to use the first formula, which says 1 over the focal length, which we know is negative 10.8, is equal to 1 over the object distance, 32.7, plus 1 over the image distance. And if you solve that, you're going to get a number. And this number should actually be negative. That image should be located to the right. And we said that if the image distance was to the right, then it's just conventionally negative. All right, next problem. Determine the focal length of a convex mirror that produces an image that is 16.0 centimeters behind the mirror, and the object is 28.5 centimeters from the mirror. Sorry, I know you have eyes, and you could have read that for yourself. All right. They want the focal length. They're telling you the image is 16 centimeters behind the mirror. That means it's negative. So wherever this is, that's a negative 16 centimeters. That's a 16. The object is more away. It's 28.5. Okay, so the equation 1 over f, which we don't know, is 1 over the object distance plus 1 over the image distance, which is a negative 16. If you're adding a negative fraction, I'll simplify it just a little bit more. It's 28.5 minus 1 over 16. And then after you calculate that, you'll have your answer. A 2.80 centimeter diameter coin is placed some distance away. Okay, so here's what that means. They're giving you the height of a coin. That's annoying. All right, a distance of 25 centimeters from the location. So let's say the coin starts here, and this distance is 25 centimeters. This coin is circular in nature, and remember that if I go all the way from endpoint to endpoint, passing through the center of the circle, that's the diameter. So that, which is also known as the height of the coin if you line it up directly. So that's 2.80 centimeters. The focal length is negative 12 centimeters, which means it's 12 centimeters behind the mirror. Sorry for my handwriting, that's just getting worse and worse. I made a lot of these videos. All right, 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance, which we don't know. I'm actually going to calculate this one. You get that the image distance comes out to be negative 8.1 centimeters. And that negative sign should make sense because it's 8.1 centimeters to the right. Now we're going to use the magnification equation to determine the diameter or the height of the image. All right, so magnification equation, the hi-ho, do it in a different color. So hi-ho, the height of the image, which we don't know. The object height is 2.80. Negative, now this negative is very important. You put this negative sign regardless of what sign your image distance is. In this case, the image distance is a negative 8.1 over the object distance, which is 25. So these negatives are going to cancel out, and you're going to get that your object height is a positive 8.1 over 25 times 2.80, whatever that comes out to be. Final question for convex mirrors. A focal point is located 20 centimeters from a convex mirror. Hope you're not finding these too difficult if you've stuck with the concave mirrors. Okay, so 20 centimeters from a convex mirror. Well, I don't really know what to think of that. Because for all these other examples, they've given focal points, yeah, focal length, and they've given it as a negative. We're going to assume that's a negative. Anytime they say focal point, anytime they say convex mirror, you know that's a negative. So it's negative 20 centimeters. When it says a focal point is located 20, I think what they actually mean is focal point's 20 centimeters from the convex mirror. It's 20 centimeters from the mirror, but they don't know in which direction. But because it says convex, we're assuming that it's negative. So I guess they're asking you to figure that out, which from these examples, hopefully you've been able to do. So 20 centimeters, we can say is right here. That's our focus, center. We'll call that negative 20 centimeters. The object is placed 12 centimeters from the mirror. Okay. Determine the image distance. 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. And whatever that comes out to be is your answer. All right, I hope that clarified things. Convex mirrors really aren't that different from concave mirrors. Just keep doing practice problems on both. Make sure you use sign conventions, and I hope that was helpful.